Guys, so yeah, I'm back. We're gonna do more in problems. Yay. Okay, whatever. A movie director wants a scene in which a car appears to fly off a cliff at 50 mph. To simulate this, the director will make a 100 scale model of the car in the cliff. Okay, and by what factor should it be sped up or slowed down in order to look realistic? And what should the real speed of the toy car be as it approaches the cliff? Okay, so let's say I have the real car. This is a real car. It's my car. Doesn't look like a car at all, actually. But I'm trying to do like the front view or whatever, the side view. So that's my real car. And I have my toy car. It's really small. So if I drop these two, they're actually gonna land at the same time. And that's actually the issue, because we're in the slums. We only got a 1/100 scale model. So we don't like, so gravity pulls the same for both. But the scale model, because it's smaller, it's gonna make it look like it's pulling bigger, right? Because you have less distance you need to cover, but gravity is still pulling the same. So that means the times will be different, right? So this toy car, it will fall in a smaller amount of time than this big car, right? Because it has less things to cover, even though gravity is still the same. I hope you guys understand that. Like, and so overall, I'm trying to say gravity, it's gonna fall the same. They're gonna fall the exact same. Mass doesn't matter. This is what Galileo proved. But but the issue is, right, we don't have a big cliff for both of them. So we have to use this 1/100 scale model, and and that means the gravity's gonna pull the same for both of them, but this is gonna have less distance to cover, which makes it faster. And yeah, that's the problem that we need to solve. So understanding the problem is like a really big part of learning physics, and I hope you understand like what I'm trying to say with that. Okay, so let's say the cliff, you can like do this absolutely. My method for this problem, like most of them, like I'll actually like use an equation, solve it, use some logic, but I just want to do plug and chug, just to put in some numbers and see what happens. Let's say this cliff is like 100 meters, right? Let's say the real cliff is 100 meters. So the real car, right? The real car, the big car, I'm just copy and paste them. The real car is gonna fall off this thing at 100 meters per second. Oh, I forgot to mention. We're gonna ignore this because this isn't the issue. The issue is gravity, and I already explained why. This doesn't really matter. It's the x direction. There's no acceleration, right? So this is gonna jump, and it's gonna be like 100 meters, and the time for it to reach the bottom is gonna be equal to, well, okay, um, 100 equals to 1/2 or -5 t squared, -100. And that's because the change in it's delta y term. So the change in the height is going to be -100. Gravity is -5. So t equals square root 20. And for our model cliff, we need a 1/100th of the scale model. So it's going to be this equation. And then 1 over 5 square root equals to t. And we're just going to plug that into our calculator real quick. Square root 20 and square root 1/5. And with this method, we want to just literally just try different values and see what happens. And we don't need to even try different values here. We can see with the real cliff, it's going to move at this time for, we're say 4.47. And with the fake cliff, it's going to fall in this time. So it's obviously falling a lot quicker, right? Here, let's 447. And this one's gonna be like equal to 4.47. So yeah, as I told, or like as I expected, as we predicted, this is gonna fall a lot quicker because gravity's gonna be pulling, and it's the same, and it's less distance to cover. So by what factor should we change it? So in order to go from the fake cliff to the real cliff, we need to multiply by 10. Exactly 10. The decimals are exactly the same, right? We need to multiply by 10, which means which means um we're gonna need to slow it down, right? Because this is faster. If it went even faster, this value would be even lower. If we slow it down, it's gonna be this value is gonna go higher. So we're gonna slow down factor factor of 10. That's the answer. We're going to slow down by a factor of 10. Everything's going to slow down. Or you can say we're going to speed it up by a factor of 1/10 or something like that. But that's really stupid. Just we're going to slow it down to by a factor of 1/10. And what is the real car of the toy? What's the real speed of the toy car? And because we're slowing everything by a factor of 1/10, it's just going to be 5 mph. Because we're just going to divide this by 10. Yeah, so that's the question. Um, yeah, it's actually pretty easy. You just need to like understand it. Yeah. So yeah, I hope you enjoyed it. If you have any questions like regarding the explanation, like I can help you out. Hopefully like in the comments. Yeah, thanks for watching my YouTube video. Yeah, bye bye.